So welcome back. Today I want to talk about feedback because there is nothing that can get the sense or vibe of a worship service off like having large, loud peals of feedback rolling through your auditorium. It is distracting, and what you find is that people stop looking to the front and they begin to look at the back, trying to figure out what the sound guy is doing. There are really three things that go into creating feedback or causing feedback problems. First and foremost is bad positioning of speakers and microphones. If my main speakers for an auditorium are behind where the microphones are placed, they are routing signal into those microphones, and that will cause problems. Likewise, if I have live wedges, monitors on the stage, and an instrumentalist sets the mic down and points it at that monitor, it is likely to cause feedback. Things that will exacerbate feedback have to do with less expensive equipment. Inexpensive microphones and speakers tend to have not as flat a frequency response. And if I have a set of microphones that happen to emphasize 400 hertz, which if you have multiple SM58s or multiple Sennheiser E35s in your church, it is emphasizing 400 hertz. It is what dynamic microphones do. It is part of the physics of the way they work. If your speaker system, either because of EQ you've applied to it or because of the tendencies of that speaker system, also emphasize 400 hertz, then you will have problems because the microphone system and the speaker system are both emphasizing a frequency, which will tend to make it roll and ring, which causes problems. Finally, what you will have are geometry-based things. If you look out in my system here, what you will see is I have a fairly small rig, but I have 4 or 5 microphones set across the front of that system. We're going to turn some of those microphones on and actually create feedback. I've got a digital console here that I have turned the gain up on too much. And at this point, it's worth a quick discursus to remind you about the different places you can turn level up and down on a mixer. All mixers have a master fader, which is turning everything at once up and down. They all have individual faders to control the level of that particular track or channel, but they also have what's called preamp gain. Now that may be a set of knobs across the top that are physical and analog, or in the case of this particular mixer, they're actually recallable, so it is a digital control. What I want to look at is if I am looking at a mix and what you see is very, very offset meters. You can see where I have 2 and 3 are very low, channel 1 is very high. If that is consistently happening, I have got my preamp set incorrectly. If I have to get this high to make this correct, I need to go into that channel and turn the preamp gain up, so that for the most part, I'm in a fairly small range as I'm turning these faders up and down. A great way to do it is actually set your master fader to unity or 0. Mind you, 0 is not all the way up. 0 is typically about 70% of the way to the top, and it will be labeled either with a U or a 0. Set those faders to unity, and then turn the mic preamp gain while somebody is speaking or playing into it until it's roughly at the level that I want it to be. If I have to trim it slightly with the fader, that's fine. That's not going to be a problem. But what I've also got going on here, if you can see, is I have what's called a real-time analyzer application on my phone. This allows me to see the frequencies as I build them up and get an idea of what's going on. There are tons of free ones. Go to the App Store, put in Real-Time Analyzer, download one. What I've done now in these instances is I have turned up the gain on these mic pre's too high so we can create feedback. So for instance, as I turn these up to about 5, if I unmute this channel, so I hear a higher frequency and a lower frequency that are ringing. If I go to my next microphone over, it is ringing at a different pitch. The third one is ringing at a different place. So they all tend to be ringing at different pitches, and they really are impacted by the geometry of the room. So this particular room that I'm in is about 47 feet tall, about 47 feet deep, and about 56 feet wide, which means, first of all, having two distances that are the same means that that frequency that is related to that wavelength is going to be emphasized more than I would like, because it's going to be emphasized both by reflections front and back and also up and down. 47 hertz ends up being about 47 feet ends up being about 25 hertz. So as we talked about with octaves, 25 hertz is probably too low to emphasize, but it's octaves, doubling that, doubling it again, and also potentially that plus 1.5. So I'm expecting there to be some problems at 100 hertz, 150 hertz, 200 hertz, 300 hertz in the room, and we'll see some of those things. But let's go chase some of those particular frequencies. So I'm going to turn on the first microphone to the left. So my RTA is telling me that low frequency that's rolling is 147 hertz. So I'm actually going to use some EQ to take that particular frequency out. While I could do it on the input channel, it's not the most effective way to do it, because they're going to tend to be lots of frequencies that are similar if microphones are in similar positions. So if I have two vocalists standing next to each other, their feedback frequencies are probably going to be similar. So I either want to have some kind of an output graphic EQ, or I want to have a built-in EQ that I'm dealing with on the output section. So on this console, I'm going to select the main outputs, and I have the ability to put EQ of up to 6 channels on this particular channel, or the output structure. So when I find that, let's get rid of that 147 hertz that tends to be rolling. I'm going to take one of my channels, and I'm going to set it to 147 hertz, and I'm going to turn it down. So now, when I start to turn this back up, you can hear that higher frequency, but that lower frequency of feedback has gone away. So let's figure out where that higher frequency of feedback is. Thinks it's at 452 hertz. So let's go into one of my channels and find 452 hertz, and then let's actually turn the gain down on that. Now watch what happens. I'm turning it up the same amount I was before, and I don't have feedback on that channel. So now I have the ability to actually mute that and move on to my next channel, which is ringing at a different frequency. So if I listen to this, and I've muted the first one, that's ringing around 5K. That really high frequency probably has something to do with the glass in the back. So I'm going to go back to one of my channels of EQ. I'm going to set this to 5 kilohertz, and I'm going to roll some of that 5 kilohertz out. You also will often have a thing called Q on this, and I'm going to set a fairly high Q so that this is a fairly narrow cut. So now when I turn this up, you can see with even at this fader at 7 or 8 dB above 0 and being very loud, I've managed to control that frequency range. Let's go to my third one. I'm going to do exactly the same thing. Create feedback, 147 hertz. So let's go find my channel that's at 147 hertz, which I have lazily set up ahead of time. Turn that down some more. Let's see where else we're getting some feedback. I'm getting some low, very low feedback. Sounds like around 100, maybe a little bit lower than that. So I'm going to go kill some of that very low frequency. Let's go to my next one and see where this is ringing. Roughly 250. So, and again, I'm just looking at the display on this to get the frequency ranges of those. I'm going to go in and take my 250 frequency and just pull some of it out. When I now turn this up, much more controlled. Now the nice thing is, I'm gonna walk to the front and just talk on a couple of these microphones, which I have now opened all of them up. More microphones means more likelihood for feedback, but I want you to hear how loud this is at the levels that I've set it.
Check, check, check. Check, check, check.
So because of where I have the gain set on these, I actually have more gain than I need. So now that I've actually set and kind of worked the system out from a frequency standpoint, I'm just gonna go in here and go back to these channels and turn the gain back to a reasonable level. So for instance, where I'm at 40 dB of gain, I probably don't need 40 dB of gain. 30, 32 is probably fine. And now I have rung this system out so it will be better behaved. This will not solve every problem I have, but this is going to make the system tend to be much more stable, and this is something anyone can do. Probably your integrator has done some of this either with a DSP or possibly with a graphic EQ on the output of your console, but the concept here is things change from when an integrator is in the room. The speed of sound changes based on temperature, so those rules for what's shifting are going to be different. You may need to be able to go and chase that. So all you need is the ability to make it feedback, an RTA to tell you what frequency it is, which might be built into your console, or you may be able to download a free app for your phone, and the ability to actually apply some output to the EQ to the output of your console. If you can do those three things, fairly simple, you've got the ability to really tame what's going on from a standpoint of feedback in your facility. And you only have to do this once. Once you've set that frequency and cut it, it's going to tend to be much better behaved. So hopefully this is something that's useful. Hopefully you're seeing some of the connections from the basics we've talked about with frequency and octaves, and also decibels and how that logarithmic scale makes difference. Most of us are not going to need 40 dB of gain on the mic inputs, but you might need that much input to actually get it to feedback really regularly. Also, don't do this with a bunch of people in the room, as they'll be very angry with you. But be aware that the response of the room will change a little bit when it's full. So you might actually have to loosen some of these EQs, whereas I might be cutting 8 or 10 dB. Once you get people in the room, you might only have to cut 6 dB. So hopefully this was useful. This will give you some ways to apply the theory that we've talked about previously. And we'll also go into some other things about the basics on mixers and EQ and compression for other applications. So hopefully this will improve your worship service.